look at another example of a question under applications of Newton's second law of motion. So the question says, three connected blocks are pulled to the right on a horizontal frictionless table by a force of magnitude 65 newtons, which is the tension 3, which is equal to tension 3. If M1 is equal to 12 kg, M2 24 kg, and M3 31 kg as shown in the figure below. So this is the figure that we are taught to say these masses are pulled to the right on a frictionless. Frictionless means there's no friction force that is opposing the motion of this of the system of these blocks. Okay, so now we are taught to say of the system. So this is A, and B, the tension in the string. Okay, so what we need to do is we just need to come up with a free body diagram for each and everything. And since the motion is in the x direction, that is what we're going to focus on. So here in this direction, we have this one for M1, and we have this T, which is T1. So we're going to have summation of forces in x is equal to M 1A. This is for M1. So here we have T1 is equal to M1A. So this is, let us call this equation 1. And for the second block, we have we have T2 and we have T1. This is M2. So the summation of forces in X should equal to M2A. So we have this one, the T2 minus the T1 should give us M2A. So let's call this equation number 2. And for M3 we have T3, and this is T2. This is M3. So the summation of forces in X should give us M3A. So what we have is T3 minus T2 should give us M3A. Okay, so we call this equation 3. Okay, so we have about 3 equations here, and we are going to proceed as follows. Let me just erase the first part. Okay, so in order for us to find the acceleration of the system, we know that these equations have the common acceleration since they are pulled by the same force and they are connected by the same spring. Okay, so we are going to add equations. So add equations 1, 2, and 3. So we have here we have T1, here we have T2 minus T1. From this and this we have plus T3 minus T2 is equal to M1A plus M2A plus M3A. So here we can see that this one and this one are going to cancel, and this one and this one are going to cancel. What we're going to have is T3 will be equal to M1A plus M2A plus M3A. So here A is common, so we can even factor out A. So A is equal to M1 plus M2 plus M3. Okay. So this one we can divide by M1 plus M2 plus M3. Even here, M1 plus M2 plus M3. And what we're going to have is our A will be T3 over M1 plus M2 plus M3, which will give us the value that we have for T3 is 65 newtons over 12 kg plus 24 kg plus 31 kg. Okay, so the value for A now, so we have A is equal to 65 newtons over, so if we add 12 plus 24 plus 31, we are going to get 67. Okay, 67 kg, which will give us 0.97 meters per second squared. So this is the acceleration of the system. Now the second part says find the tension in the rope. So the tension in the rope. So tension. So we can use any of the equations. So in this case, we're going to use T1 is equal to M1A, which was the first equation. So our M1 is that is 12. Okay, 12 times our A, 0.97. Okay, and what we're going to have is 11.64 newtons as the tension